Hey guys, how's it going? I guess before we get started, I just want to, first time in Istanbul, beautiful city. I've been really enjoying all the Turkish food. I had some, it was menemen yesterday for breakfast. Absolutely delicious. You can get quite I live back in New York, and you can get quite a bit of Turkish food there, but it's like another level here in Istanbul. So today I'm going to talk a little bit about Aleo. We are a layer 1 zero knowledge protocol. I'm going to talk a little bit about our infrastructure and just kind of give you a high level overview of what we've been working on and talk a little bit about how we're thinking about some of the problems that our previous presenter was discussing. So I guess we'll start off by talking a little bit about the history of Web3 in general. We started off with ideas on how can we create digital cash, right? None of these were particularly successful, and all because of one large problem that I'm sure many of you are familiar with, the Byzantine Generals Problem, right? These early solutions either had issues in centralization or issues in double spending or other attacks that made them not ideal. So once some of these problems were solved, Bitcoin was created, right? The Bitcoin white paper from Satoshi solved that Byzantine general problem and created our first version of decentralized cash. There were some advancements to that, mostly around scalability or privacy. Litecoin, etc., kind of ways to try to scale the network, increase the speed, whereas Zcash was an attempt to increase the level of privacy from Bitcoin. Our next step, and probably where I would say, if this was like a pie chart today, would be probably about 80 or 90% of this entire ecosystem, right? Are execution environments like Ethereum, like Near, Cosmos, Polkadot, etc. That's kind of where we are today. That's where a lot of the effort and development is being focused on, is how can we execute functions, any function, decentralized and safely, right? What is the major problem with, and it's not a problem for everybody, but what is the major issue with doing public execution? Privacy, right? I can go and look at your wallet or your wallet or your wallet and see everything that you've ever done. And for some applications, this is totally fine, right? Not everything needs to be private, but I think one of the largest use cases we've seen in Web3 is financial applications. And most people would prefer if their finances are private. And so here we then have Aleo, which we at Aleo look at it as like an evolution or the next step in decentralized systems, right? And really the core thing here is that we're combining execution with privacy by default, right? So built into the infrastructure, built into the design, you get privacy without having to do anything extra. You don't have to use a rollup. You don't have to, it's just baked in. And we're gonna talk about that today. Here's another cute slide on, so again, right, we went from public money to private money and execution, public applications, but now we can do privacy and money and execution all at once. And so if you want a quick way to think about how Aleo works under the hood, it uses the UTXO or a model similar to UTXO from Zcash, but execution environment like Ethereum. So it's kind of a child of these two concepts. Again, right, early systems might have been decentralized, may have been interoperable, however, no privacy. And that's really the problem that we're looking to solve. Cool, so some of the exciting, one unique part of the infrastructure at Aleo is that we have two main networks, or I like to think of them as networks. We have a decentralized prover network that executes off-chain executions, wraps them up in a proof, and submits them to validators for consensus. So all of the execution, and Aleo actually stands for Autonomous Ledger Executions Off-Chain. So this is a really core concept, is that program executions happen off-chain. They can be of any size runtime, because at the end of the day, they're wrapped into a succinct proof and submitted to a validator for consensus. So if you look at on-chain data, what you see are encrypted proofs and some metadata, because we also support public state as well. Not everything has to be private. If you want to build a fully public app, just like you can on EVM, you can do that as well. One of the neat outcomes of this is that gas prices are fixed. There's no congestion pricing, right? You have a read costs what a read costs, a write costs what a write costs, because you're not fighting for block space. And hypothetically, if you wanted to run a computation forever, you can do that since it's off-chain. Wrap it in a proof. The proof is always the same size. You're always proving the same amount of bits, so you can do that, which is a nice benefit that, of course, is not currently possible in some other execution models that are out there. And right, you can kind of, like I mentioned on the cost of execution, looks more like a logarithmic scale than it does, when congestion goes up, we don't have this exponential curve. So how do we do that, right? What are the main pieces of infrastructure that our team has built to implement this model? One is SnarkOS, which some of you may be familiar with. This is essentially our node software. This is how you'd run a validator, a prover, a client, etc. Then there's SnarkVM, which executes our DSL, Leo. Leo is a pretty high-level programming language that is used to build circuits. You deploy these circuits on chain to validators, and provers can then execute the functions that are contained within. This is a cute diagram that kind of explains, it's an iceberg analogy, right? So at the top of our iceberg, we have our Aleo web app SDK. So we also have a full JavaScript SDK for interacting with programs on chain, for building UIs. If you're familiar with Create React App, we've created our own version of that, so you can quickly spin up a full stack app using just a couple lines of code. Leo is a high-level programming language for building circuits, and it compiles into Aleo instructions, which looks a little bit like assembly, if you're familiar with that. And then we have SnarkOS and SnarkVM, which are really at the infrastructure level. So what's the main idea here? Like, why are we bothering to build this, right? Privacy is one component, but I think something that you'll probably all agree with is that today, building apps with ZK is really difficult. It requires either advanced knowledge, maybe a master's or a PhD in math or computer science, and it's still, even if you are an experienced software engineer, not very accessible. And that's a problem that we're looking to change. Leo is one step towards that. We wanted to provide a programming language that looks like what engineers and developers are already used to, while abstracting away all of the complexity of the underlying ZK technology. And so I mentioned earlier that our execution model and data model looks a little more like UTXO than it does the account model that you'll see in Ethereum. And so we call this the record model, which is our data primitive. So similar to UTXO, a transaction must have an input record and will produce output records. This is a bit more, we can talk a little bit more about the infrastructure, right? So again, validators are running nodes on SnarkOS. Provers execute code using SnarkVM. And developers write in a high-level programming language called Leo. They deploy their apps to validators, like this. So what that looks like is you'd submit a deployment transaction, and consensus would agree, this program looks good, everything's okay. It's added to the program registry, and it's deployed. If we wanted to execute a transaction, we would be interacting with a prover. What that looks like is a user submits an execution request to the prover network. One of the provers picks it up. They use a proof of work system to incentivize provers to run fast hardware, to generate proofs as fast as they can. If the program looks good, parameters look good, it matches a function and program definition that's in the registry, it's executed, a proof is output, and submitted to a validator to be finalized. So the finalized step is essentially where this prover network and the proof of consensus validator network speak. Again, you can see the only difference here between a deployment and an execution. Still doing a consensus check. However, we are now using completely encrypted data. The programs on chain are public. You can see their code, similar to what you might do in Etherscan. However, when we're dealing with transaction executions, all of the data contained within there is encrypted. And the only person, we use the record model to do this, right? So if you submit a transaction, you're the owner of this record, and that record is encrypted using your key, whoever submitted the transaction, and only you can decrypt the record. So if you wanted to crawl a chain and get the history of all your individual transactions, you can do that because you have the private key to decrypt all of the records that you own. However, nobody else can do that. Only you have access to your own data. So again, just reiterating that the main goal here is to make building ZK apps easy, make it fluid, and help reduce some of the barriers that currently exist today to deploying and building consumer-level, enterprise-grade ZK apps. So we like to think of this as a bit of a new model. It sounds pretty similar to the Ethereum model, right? You're still wrapping things in this case, in the EVM model, in order to implement ZK, typically what people are doing are building layer 2 rollups, right? And the model sounds pretty similar to what I said here with Aleo, right? Where in our case, we have a decentralized prover network as opposed to some team that's running a layer 2 to do the ZK rollup. There are some issues with ZK rollups. Some of them are centralized. Somebody has to run the hardware. And this is one problem that we looked to solve with our prover network. We still use proof of stake consensus. If you're curious, it's an implementation of Bullshark and Narwhal. You can check more about that online. And of course, both ecosystems have developers. So what's interesting about ZK? What are some of the use cases that are available that might not be possible if you're in a completely public system? Why are you guys all here, and why is everybody excited about ZK in the first place? If privacy was the only reason, I don't think that would be enticing enough necessarily to get everybody here. So there has to be some type of new application, something exciting that just hasn't been able to be done before, that's getting everyone so excited. And so let's talk about those a little bit. One are zero-knowledge token swaps, right? So earlier today, I talked a little bit about, if you executed a bunch of trades on chain, I could just go and look at all of them, right? I can see everything that you've ever done. If you bought a gift for your mom, or you sent money to your grandma, I can see that, right? Verifiable oracles, I think, is another interesting use case. You can provide data to an oracle without revealing who you are, and it can be verified, right? You can use a verifiable credential and make sure that this data is legit. Whereas currently, that can be pretty hard to do if you don't want to reveal who you are, but you want to verify the data, there's a bit of an issue there. Another thing, and so I know this might sound confusing, right? Privacy and compliance. How do these two things go hand to hand? And our previous presenter kind of mentioned it as one of the challenges is that you have to KYC pretty much everybody in order for them to do private transactions legally in most governments under most authorities. And so we're actually building a product called Zpass that recently launched that helps do KYC very easily on the chain. So if you are building a protocol, you're building a privacy app, you can easily integrate KYC into your app and hopefully not have to worry or do all that effort yourself. I think zero-knowledge gaming is a really, really interesting use case. There's a whole category of games that you can't effectively implement on a public ledger. I would call them imperfect information games. And this is a really wide. Most casino games fit this model, but even something more fun like StarCraft also would be considered an imperfect information game, right? There's information that the one player has that the other player doesn't have, and if that's public on chain, you can't do it. I could look at what units you've built or what the state of your base is at any time. And any fog of war style game or casino game where there's hidden information, Texas Hold'em, Baccarat, really almost all of them, fit this category and are very difficult to implement properly on a public ledger. Privacy preserving machine learning. I like this one too. What I like to say about this one is, for example, I love LLMs. They make my life easy. I use ChatGPT and other LLMs all the time to do my work, right? However, I don't love how much data it takes to train them. And that, of course, some of that data has to be mine. We all contribute in some way or another to LLMs by, doing things on the internet, by, having your Alexa listen to you while you're at home, or your iPhone or whatever. And so if you can use ZK to put a barrier in between providing this data and your identity. And then you can provide your data to LLMs, get the benefits of them improving with more data without revealing who you are or getting an Instagram ad 2 minutes after you mentioned something to your phone. And then of course there's tons of applications for doing authentication and identity. I think that's like a very natural fit for ZK. And so you might be wondering, how can you get involved? Well, we have a couple ways to get involved. If you are a developer or a team and you're looking for funding, one way that we do that is via our grants program. That's something that my team runs. If you want to come speak to me after, I'd be happy to talk to you, or you can check out aleo.org/grants. If you're a Rust developer, we have a bug bounty program. If you want to check out the protocol in depth and find bugs, we'll pay you to report them and fix them. And then also, we do lots of hackathons. We're actually doing some hackathons this week. Elio is hosting a hackathon where I think we're giving out, I think there's up to 50 or 60,000 in prizes. And we'll also be at ETH Global. And we're participating in ZK Hack right now. Yeah. So ZK Hack's going on right now. We're doing a Learn and Earn program on Wednesday where you can earn up to $600 to attend workshops, to just learn about Aleo. We have a bunch of people giving workshops and teaching. And then we're doing a hacker house, and the hackathon's going on this entire time. We're also doing an event called Snark Tank, which is like a pitch competition for ZK startups, which I'm super, super excited about. So that's all. If you want to view more ZK House information, please scan this here. Yeah, so you can scan this one here, and you should be good to go. Thank you for your time. I will take any questions if anybody has any.
Do we have